Hi and welcome back. In this lecture, I'll show you a few examples of one-to-many relationships. A one-to-many relationship allows a single record in one table to be related to multiple records in another table, and this is one of the most commonly used type of relationships. So let's see an example from our database. Let's look at the relationship between products and brands. As you can see in the example, one or more products belong to a brand. That means that between products and brands, there is a many-to-one relationship. If you look the other way around, there is a one-to-many relationship between brands and products. Or in other words, a brand has many products. Basically, the one thing you should note here is that one-to-many and many-to-one is the same relationship. Nothing changes in the DB. It just depends from which side you look at it. Okay, that being said, before we move to our next example, let's update the design in MySQL Workbench. Now, before I'll create the relationship between products and brands, I want to discuss about the brand's primary key. So even if we could use the brand name as the primary key in the brands table, because no two brands have the same name, I'll add an ID column of type int, which will be a number. Why is that? Well, in most web applications, it is easier to work with IDs which are numbers, and on a second thought, we do a small size optimization. Imagine that you have 1000 iPhones in your store, and for every one of them you have to specify the foreign key to the brand as the word Apple instead of a number like 1. Obviously that will take much more storage. So I'll go ahead and create the ID column of type int, set it as the primary key, and I'll remove the brand as the primary key. I'll move the primary key as being the first column, and then I'll replace the brand name with name, simple as that. Okay. And now let's create the relationship. So I'll choose a one-to-many relationship and click on the products and then on the brands, and that's it. The relationship has been created. And as you can see, MySQL added by default a brands ID foreign key in the products table. Now what I'll do, I'll remove the brand column from here, since it has been replaced with the brands ID foreign key, and we are done. Now let's move on with our examples. Imagine the products table. As it is now, we are using some assign IDs for our products. Considering that every product in the world has a unique serial number, do you think we could use that in place of our ID? Of course we can, and probably everything will become better integrated with the cash register. To make a parenthesis, for mobile phones, this serial number is called IMEI code, and you can find it on their backs or on their menu, and using it you can verify the phone's authenticity. Let's use that as the ID. Okay, now let's add a few more products to our table. Imagine you have in your store 3 iPhone 7s. You could as well have 1000. Do you see some data redundancy here? In other words, repeating data? Well, the name, tagline, description, price, brand, and warranty are repeating for every product, as you can see for the iPhone 7. We should remove that data redundancy from our design. So how could we do that, you may ask? Well, imagine that every product we have is actually a physical item with a unique serial number. The name, description, brand, etc. are attributes that are the same for each item and represent the product, in our case iPhone 7. They could be extracted in some other table. Think for a moment, how would you do that? Ready? Let me show you how I would. I'd break this data in 2 tables. One is called products and store generic data about the product, and the other is called item. Here we store specific item related data. This new relationship between products and items is a one-to-many relationship. A product can have multiple items, or if we look from the other side, more items belong to a product. Does this make sense? I want to show you a few more details so that you better understand the advantages. Imagine the iPhone 7s. You want to store the production date. Where will you do that? In the items table or in the products table? Well, you are right, not every phone was produced on the same date, so the production date becomes an attribute specific to a product item. Now let's see where other attributes could be placed. How about weight? Items or products? Products, right? Every item should have the same weight since it's the same product. How about location? Imagine you own multiple stores at different locations. Where would you store the location? You are right, on the item. Okay, I hope things are clear now. Let's move on and update the DB design. So here we are again. And I think the easiest way to do it is to add the items table. Add the ID column, which will be the primary key. And what else? Let's store the production date. Of type date. Okay, that's good. Now let's build the relationship between products and items. So we want many items to belong to a product. And that's it. I'll just move these tables around to be easier to see. So now an item has been linked to the products, and as you can see, the multiple side of the relationship is here on the items. That's it. Let's move on. Let's review the products to products category relationship. Remember, we split the tables like this when we discussed about the first normal form. In this form, a product belongs to one or more categories, so they are in a one-to-many relationship. Now imagine we add another product and assign it to the same categories. Suddenly, we emulate, and I say emulate because it's not by the book, a many-to-many relationship between products and categories. A product belongs to multiple categories and a category can have multiple products. Well, theoretically, if you keep the categories as simple strings, this could work, but this is not optimal. First of all, imagine that you could have 1000 smartphones. That means that in the products category table, you'll have to repeat the word smartphones 1000 times and another 1000 times the word phones. Lots of redundancy. Next, imagine we add a category description. That will look like this. Besides having lots of redundancy, this table is not in the second normal form. Taking into account that product ID and category form the composite primary key, description does not depend on the product. So we'll have to split the table like in this example. What we have accomplished now is preparing the tables for a proper many-to-many relationship. Join me in the next lecture to see how it works and to see more examples. Thanks, see you in a sec.